Alright, we're working today on your circles review. Let's get right into it. When we have a radius to the diameter, we just doubled it, so 8 inches. To get circumference, we just add pi to the diameter, so 8 pi inches. Area is pi r squared, so 16, because 4 squared is 16 pi, your unit is inches squared. For this one, if you're given diameter, just cut it in half to get the radius. To get the circumference, you do 14 pi, just add pi from the diameter. And then your radius squared gives you 49 times pi, unit is inches squared. For number 3, we know the circumference is 40 pi. That means the diameter is just the same without the pi. That means the radius is half of that, which is 20 inches. Then 20 squared is 400 pi r squared, so we need pi inches squared. And the last one, the area is 144 pi r squared. That means this is r squared. That means the radius is the square root of that, which is 12. Which means the diameter is double that, which is 24, and the circumference is just add pi, 24 pi inches there. Alright, for these ones, with the pi graphs here, the measure of angle BAC, that is this little pi right here, which is 10%. We need to say, well, 10%, that's 0.10 as a decimal. We need to multiply that by what would be entire full feet, which is 360. That's all you have to do. The percentage of the decimal times the full amount, which is 360. So this one ends up being 36 degrees. For EAB, we have the 30% pi here, so that's 0.3 times 360, and that one's going to end up being 108 degrees. For BED, the arc, it works the same way. A combined of 63% here, so 0.63 times 360. And this angle ends up being 226.8 degrees. Then the last one, EBC, so that combines these two regions, which is 43%. So 0.43 is the decimal times 360, which ends up being 154.8 degrees for that one. Alright, looking at the next section, we are finding the length of these tangents. The big thing is, when I have tangents, they must be equal to each other. So I'm just going to set these equal. 14x minus 10 equals 11x plus 8. Subtract 11x from both sides, add 10 to both sides. And that gives me x equals 6. Then all I have to do is plug back in. They want to know BD, so I just plug it back in. When I do that, 14 times 6 gives me 84, minus 10 gives me 74. So my final answer there is 74. Same thing here, 12x minus 11 equals 10x plus b, or 10x plus 8 I mean. Subtract 10x, give you 2x, add the 11, which will give you 19, that means x equals 9.5. I plug back in for either one of them, and I get BD will equal 103. Last one, again, 7 equals, so 17x minus 15 equals 13x plus 3. Subtract 13x from both sides, gives you 4x. Adding the 15 gives you 18 over here. I should get x equals 4.5, 4.5. And again, I just plug back into either one of these, and I'll get 61.5 as my value for segment BD. Alright, next one, arc length and sector area. These are the exact same. We have two different ways to do it. So the first way I can do with arc length is by setting up a proportion. So my 47 degrees out of a partial total of 360 equals my arc length, which is a partial out of the entire perimeter. The entire perimeter is 2 pi r, which would be 2 times pi times 8. From there, I would cross multiply and divide, which means I have 47 times 16 pi, for this cross multiplying, equals 360 times x. And when I solve that, I should get x equals 6.56 inches as my answer. For the sector area, it's the exact same formula. 47 over 360 equals x over, now instead of the perimeter formula, now I'm going to use the area formula, which is pi times r squared, so pi times 64. So that means I have 64 pi times 47 equals 360 times x. I divide both sides by 360. I should get x equals 26.25 inches squared. If you prefer, you could have left these in terms of pi. This would have been, I think, like 2.02 pi, something like that. Those would be just fine. Now, the other way you could solve these, I'll do that for number 13. The other way would be just taking your formula. So for arc length, we should use the formula for perimeter. So again, 2 pi r, in this case, 2 times pi times 12, and then multiply that by the fraction 122 over 360. So when I do that, it just gives me a straight up answer. In this case, it would be 25.55 inches. I would do the same thing for sector area. I have the 122 over 360, and I'm multiplying it by now my area formula. So pi times r squared, 144 pi. And this gives me an answer of 153.31. My unit here is going to be inches squared. Alright, number 14, I would do another one with proportion. I would set this proportion up as 168 over 360 is equal to, I don't know, over 2 pi r. 2 times pi times the radius is 4. So I should get 8 pi times 168 equals x times 360, which means x is going to equal, when I divide by 360, I should get 11.73 inches. For sector area over here, same formula, 168 over 360 will equal x over pi r squared. So this should be 16 pi r squared. So I mean 16 pi times 168 will equal 360x, which means I should get x when I divide by 360 to be 23.46 square inches. Over here, I'll do another one like 13. I'll do my fraction, so 33 over 360, and multiply it by this one, the perimeter, which is 2 pi r. And then for sector area, 33 over 360, and multiply it by pi r squared. So that would be pi times r squared. 2 squared, the r here was 2. Well, here's the deal. On this one, I'll get 33 over 360 times 4 pi. That's exactly what I get here. 33 over 360 times 4 pi. So I'm going to get the exact same answer for this. Both answers end up being 1.15. My unit up here is inches. My unit down here is always inches squared. Alright, on to the next set of problems. We are now trying to solve for x. The main thing for 16 and 18, when we have inscribed triangles, the angle that is not touching the diameter is always a right angle. So I'm just going to set these equal to 90 degrees. When I do that, I'll add 6 to both sides, so 12x equals 96, which gives me x equals 8 for that one. And as for number 18, I should have adding 15, so 11x equals 105. Divide by 11, I do get a decimal. If I leave it 105 over 11, that's fine. At a decimal, that would be 9.54. Now, for 17 and 19, a little bit trickier. All you need to do is either set A and C equal to 180, or set B and D equal to 180. The opposite angles equal to 180. So add them up. So I'll do A and C as an example. 16x minus 4 plus 3x minus 1 equals 180. That means I have 19x minus 5 equals 180. So 19x equals 185, which means x equals, in this case, it would be 9.21. If you did B and D, you actually would have gotten a different answer the way this problem was set up. For 19, let me do B and D. I would set those up. I would have a total of 18 x's between the two of them, minus 10 to equal 180. That means I should have 18x will equal 190. That means I should get x equals 10.56 for this one. Many different answers you get, whether you do B and D, whether you do A and C, or whether you add them all up. But mainly you need to show me that you can pick two together and set them equal to 180. Alright, number 20 through 22, inscribed angles here. The inscribed angle is always half of the arc intercept. So if this is 81, that means the arc intercept is double that, 162 degrees. So arc BC is 162 degrees, and that means the arc CAB, going the other way, 360 minus 162, because it's the major arc compared to this minor arc. So this answer should be 198. That's just 360 minus 162. For number 21, we need to find the measure of arc DAC. Well, DAC is this big arc out here, so we'll hang on to that for a minute. The other thing we need to know is the measure of arc BC. Well, that one's a little bit easier to find to start with. If this is 70, then it's doubled to get the outside, so that's 140. Now, to find what we have for the rest of the way around, for DAC, that's going all here. Well, that's everything but 82. 360 minus 82. So what I should get for that, is not what I have on here. It's not the arc DAC. They wanted the angle DAC. So they wanted this angle looking in. Well, it needs to be half of 42, or half of 82, which is 41 degrees. That's why 41 is your answer there. And now for 22, we need the measure of angle DAB and the measure of angle DAC. Well, those are pretty easy. DAB, cut that arc angle in half, so that's going to be, it should be 46 degrees as a result, and cut this angle in half is just for DAC. Well, this part is 40 degrees, so I need to double it to get this entire thing. So DAC would be 46 and 40, which is 86. DAB is just that little portion, which was 46 as a answer. All right, coming down the home stretch, number 23, we need to find a couple different things here. The main issue here, this interior angle, 40, must be half of the sum of these two outer angles. So if this is 40, that means the sum of the outer two must be 80. Well, I already have 50 for this side, that means this side needs to be 30. So this arc BD must be 30 degrees. And now, AEC, well, that's just a vertical angle, so that has to be the same as the one across from it of 40 degrees. For number 24, what we're looking at here, 110 plus 182 gives you 192 for a total for these two arcs. That means that the angles inside here must be the exact same, must be half of that. So that means the measure of HKG here will be half of that, which is 96 degrees. So that's this answer is 96 degrees. And then HKI, well, they need to form a linear pair. So that means this has to be 84 because they need to add up to be 180 degrees. So these ones down here, any arc made with or any angle made with a tangent is exactly like an inscribed angle. It's half of the arc length that it intersects. So MLN to start with, we'll start with that. It's an inscribed angle. These two angles add up to be 148. That means that this angle on the inside needs to be half of that. So that's why this angle here is 74 degrees. Now as for PLN, PLN must be half of the arc it intersects. So half of 48, which is 24 degrees. And now for 26, measure of arc QT, that's this arc out here, it's intercepted by this angle, so that means it needs to be doubled it, which is 40 degrees. And then RTS needs to be half of that arc, half of 130, which is 65 degrees. So this is 65 degrees. Alright, the last ones deal with chord lengths and sector lengths. When we have two chords, like in 27 and 29, all we do is the two pieces that are together, and we multiply them. So 6 times x, it must be equal to the other two pieces. It must be equal to 3 times 4. So 6x equals 12, which means x equals 2. So to find out what these distances are, if x is 2, 2 plus 6 to give you AD would be 8, and then 3 plus 4 gives you 7 for BC. Let's do number 29. It's the same way. My two pieces are 4x for those ones together, a 4 and an x, and then a 10 times a 10. So 4x equals 100, which means x equals 25. So that means CD, if we have 25 here, that means CD now is going to be 29 total, and AB, 10 plus 10, is 20 total. So without even doing any math, you should have found both AB and number 27, BC. Now, for the ones with the sectors, it's a little bit tougher. We always say we need the little piece on the outside and the whole big piece. And then the little piece and the whole big piece. So for the top part, I have 2 for the little piece, and the whole big piece would be a 2 plus x. For the bottom part, it would be 1 for the little piece, and then 1 plus 4, which is 5 for the big piece. Now I just distribute. I get 4 plus 2x will equal 1 times 5 is 5. That means 2x equals 1, or x equals 1/2 as my answer. So then that means when I plug these in, for CE, 4 plus 1 is 5. That's pretty easy to find. And then AE is going to be 2 plus a half, so 2.5, 2.5 as your answer. And then 30, the last one here, again, we're going to do piece and whole, piece and whole. The piece is 3 for the top, and the whole is 7. The piece is 2 for the bottom, and and then the whole thing is 2 plus x again. So 21 equals 4 plus 2x. So that means I get 17 to equal 2x, which means x equals, I'll just leave it as 17 over 2. You made it a decimal, that would be 8.5. Now you just have to plug in. AE, you already know though, is 7. CE would be 8.5 plus 2, so that should be 10.5. Or if you did it as a fraction, that would be 21 halves. Well, there you have it. Everything that you could ever possibly want to know about circles, and then some. Good luck. Have a good night.